So for this one, sorry, you might have to see me today. Hi. We're just going to review some stuff, and I want to draw some pictures. So make sure you have your periodic table. Again, if you don't, pause it and be good. Sorry about the glare coming from here, but it's totally dreary out right now. And I'm recording this. So here's what I want you to remember from the last video that we did. Okay, atoms are neutral. They're the way they found in nature. Protons always equal electrons. Remember, protons define what the atom actually is. All right. Isotopes are pairs of atoms that are found in nature, things like carbon 12, carbon 13, carbon 14, et cetera, et cetera, et cetera. Today, we're going to work on ions. And these are simply charged atoms where the protons do not equal the electrons anymore because they were not happy, stable, and content. Okay, so what am I talking about with this? Okay, so here's fluorine. Okay, and here's where we need to be. Okay, and if you're not, you're kind of behind, and it's okay. This is what I want you to do on your drawings. And I tried to help you out with these the other day as well. If I look at fluorine, it's got number 9. So it's like that. Okay. Now we know that atoms are neutral, and so it's got 9 electrons in there as well. Now the mass of fluorine is 19, so when I subtract, it should look like this. So your drawings for fluorine should have been 9 positive, 10 neutrons. Much better than me trying to do Sketchpad. This is my daughter's easel, by the way. All right, put 2 in the first shell, because remember our rules are always 2, 8, 8, and I'll move my arm in a second. 18, 18, 32, 32. Okay, those are our rules for how we fill those energy levels in the outside. Okay, so I put 2 in the first, and it's good. Now I need 7 more because I add up to 9 total. So I draw my one right here. Put 1, 2, 3, 4, 5, 6, 7. Okay. Now, this row wants 8. It only has 7. So it is not, it is in the atom form right now. Protons and electrons equal each other, but it's not in this happy octet folding rule. Remember, we got to follow the octet rule. If you didn't watch the last video, all right, you need to make sure you do that. So you got to do the octet rule. So do the octet rule. What happens is this, all right, is it is going to go on the hunt. And we'll talk more about this in the next chapter, all right, as we go through this. But it's going to go out and hunt, and it's going to go try to find an electron from somewhere. And it's going to go out and steal it and pull it towards itself and bring it all the way in here. Now, that octet, now that rule is, now that whole thing is full, stable, content. And now this isn't right anymore because my protons and electrons don't equal. Remember, I didn't change anything in here. When we talked about the layers in here, we can't get to that. And now this becomes a 10. And now this becomes fluorine with a -1 charge. Do you remember what kind of ion that is with a negative charge? It's an anion. So this is how fluorine makes itself happy. It's happy, it's stable, it's content, it's perfect. But where does it get one of these from? All right, I'm going to try to tilt this down just a little bit. All right, so where does it get this from? It gets it from sodium. Okay, it gets it from sodium. Now, if you go to sodium, now it doesn't have to be sodium, it can be other things as well, but it gets it from something like sodium. So if you go to this, it's 11, it's 12, and it's 11. So there's my 11 plus, there's my 12, and this is what I wanted you to do on the first set of drawings. Some of you guys forgot this part here, okay? 2 in the first, 8 in the second, because we're following our octet rules up here, right? And then we have one more layer out here. And it's got that one little electron sitting out there, okay? So the deal is this. We want to make these fit here. We want to make them be stable, okay? So this has one too many, all right? So it like gives it away, okay? This thing right here is trying to hunt to look for one. It's got one right here available. So it's going to kick this one out. See ya, get out, okay? Go over here. When that happens, watch. This entire thing goes away. All right, this entire thing goes away. That entire shell goes away. Okay. Now you say to yourself, well, where did it go? It's always there, just nothing's in it now. And now it's full. It has its 8, it's happy. But again, this changed. And so that's now a 10. Now, this has one more proton than it has here, which is why we give this one an Na with a +1 charge. Now, you can write it that way, or you can write it like this. It really does not matter. I like writing it that way, but some people don't, so it's okay. Okay? But the idea for this, okay, is that this can't happen without this. You have to have something to go get it from. So that's why I talked about how elements have to react together to make that happen. So it what happens is these two get close together. This one gives up its electron because it doesn't want it anyway. This one will then take it, steal it, bring it towards itself, and form this lovely thing. So what about the plus twos and minus twos and things like that that we talked about before? Okay. Well, the idea is this. Let's look at oxygen. Okay. Oxygen. Go back to my black here because I like the different colors for you guys. Sorry. All right. Oxygen has penny of 8, 8, 8. So 8 positive, 8 neutrons. Boom. 2 in the first. 1, 2, 3, 4, 5, 6. And now everything matched up. So that's what your atom drawing should look like. Okay, this is what your atom drawing should look like here. So the idea is this: in order to be stable, it's got to fulfill that rule. It's got to fulfill 8. That's what the octet rule is. Sorry, you guys can't really see the octet rule part. That's up there, got cut off on the screen. All right, but the idea here is it's got 6. It needs 2 more. So it's going to find something like the sodium or calcium or something that doesn't want these things. Not that you guys know that yet. All right, it's going to go and pull it towards itself to make itself stable. Now look, now our octet rule, now our valence shell, that last shell on the outside is all full, which changes that to a 10, which changes this to O with what charge? It's got 2 more negatives than it does positive, so we say it's -2. I always say, however many you bring in to be happy, that's negative. If you kick out, it's a positive, all right? So this is how this stuff works. Now, again, it can get it from any of those things that want to give them up on the other side, okay? And sometimes they want to give up like 3 of them or whatever it is. Doesn't matter. We'll figure out how they match up later on, okay? Let's look real quick at aluminum. Aluminum has a penny of 13, 14, 13. So 13 plus 14n. We don't really care about that middle part. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. I'm just following my rules. Nice one right there. That's 10. I need 3 more. 1, 2, 3. This level, this shell is not full. This shell is not happy. This shell is not content. Okay. So what it wants to do is it wants to kick it. It does whatever is easiest. It can either gain 5 right here, which is really hard to do, or it can lose 3. So it's going to go like this, and like this. And when that happens, when those go away, that whole thing, that whole shell goes away. And now that shell is full, happy, and content. And so now those electrons are going to go to something that needs them and makes them happy and all that other kind of stuff. That changes that to a 10 and makes aluminum, when it turns into an ion, okay, a +3 charge, okay, for what I want you guys to have. And that's how this works. Now, what about one where it's harder to do? It's not really hard to do. Well, let's look at carbon. Carbon is 6, 6, 6 for its penny. 6 plus 6n, 2 in the first. 1, 2, 3, 4. It is just as easy for it to dump 4. They can kick those 4 out as it is to gain 4. All right, so carbon can be a +4 if it pulls it in, or it can be a -4 if it kicks it out. Okay, so carbon's got a very special, unique thing because it can do both of those things. Okay, all right, so that is your little sketches for what I want you to understand about ions are. So what I want you to do is I want you to look at your drawings. First off, if they don't look like mine, you need to fix them because I want you to use them. This is going to be open book, open note test for the stuff we're going to deal with here. And I want you to use them. So take your periodic table, draw those first 18 of them or whatever and try to fix them. And then what I want you to do is I want you to go and try to show what kind of ions they are. Now, you don't have to show me these. We're going to practice a couple of these in the next video. You don't have to show me that. But your assignment for what I want you guys to work on is going to be this packet right here, this Exploring Atoms packet. But, turn it towards me a little bit. Hi, guys. All right. It's going to be this packet right here. Now, they got questions right here about matter, drawing, all that atom, all that kind of stuff. These are the questions that I want you to answer. Okay. All of these questions through here. You don't have to worry about, doing anything else, but this packet's kind of confusing for people because then you get this. This is your answer sheet if you want to use it. Okay. You don't have to. You have 14 questions I want you to do for homework today. You don't have to use this answer sheet. You can just write it right along here if you want to, or right along here. But if you want to make it easier for your submission, there's where you put the first 11 on this page. This is the little introduction page. Sorry, it's so bright behind you right now. All right. And then there's 12 through 14 on the activity page. Okay. So do this. Now, I'm going to make you have a rule here. Okay. Everything has to be submitted on Canvas now. You've practiced it, you've done all that kind of stuff, and you read the assignment. That's what I want. So basically, you need to take a picture of this filled out when it's done, and take a picture of this filled out when it's done, and send it to me on a file just like you did in the last one. Okay. If you have any problems, email me, talk to me, call me, whatever. Do it. Not won't call me, but email me, get a hold of me, and I will help you out. But you should be able to do that kind of stuff by now. Okay. We're gonna do a lot more videos like this where I can show you things. I think it's a lot easier than me trying to draw on that sketch pad and things like that. So you can actually see what I'm talking about as I'm talking about it. Okay. So again, just remember, going back to this thing, and I know it's kind of hard to read the glare. Atoms are neutral, all right, found in nature. So when we did your first drawings, we were drawing atoms. Isotopes are the thing we talk about next, just because we wanted to know why we had those decimals in those answers, okay, in those masses. And so that's why we looked at where those things from. We don't really do a whole lot with those. Again, if we're back and I get to teach you about radioactivity, we'll dive into that a lot more in a lot more detail. But then today we're talking about ions and showing them how they react, because they're going to be massively important to the next chapter as far as how all these other kind of things work out, as far as where the things go in the families and studying the periodic table. Okay. If you guys haven't figured it out, obviously we're not in school till May 1st, so we're going to be a little bit slower pace. We're trying to get through as much as we can. Next video, next what we're going to do on Wednesday is going to be basically a review day. Basically, is looking at making sure we're all understanding atoms and ions and drawing things together and trying that. I want you to practice along with me, just like we do in class. All right, and hopefully you'll be okay with that. Okay. Again, have any problems? Email me, and we will talk to you guys later. Have a great day. Try to get this assignment done, turned in on time. All right, don't be late. All right, you lose 5 points every time you're late from now on, so just make sure you're okay. All right.